All right, so we're on to the next one here with the Rados Gateway. Now we're talking about the Hadoop file interface for the Rados Gateway caching tier. Do you guys want to introduce this one a little bit?
Sure. Thanks, Patrick. So the background is we tend to build some reference solution for Hadoop over Ceph RGW. Sorry, we tend to build some reference solution for Hadoop over Ceph. We tend to follow the Hadoop OpenStack Sahara project, which is built on Hadoop over Swift, and so we'd like to share this design with Ceph community, and would like to hear some comments from you guys. So can you see my screen now?
Mm-hmm. Yep.
Okay. So there's a special requirement in this solution that all the storage servers are actually in an isolated network with the Hadoop cluster. That actually prevents us from using Hadoop plus Ceph RGW plugin, which requires Ceph cluster and the Hadoop cluster sit in the same network. So we turn to use Ceph Rados Gateway. In this solution, Ceph Rados Gateway will play as a connector of these two networks. Plus, we are going to leverage Ceph cache tier technology to cache the data in each Rados Gateway server using SSD. Okay, so this is a general proposal of our solution. You can see from the left picture, we actually have four components related with Ceph. The first is RGWFS, which is actually a plugin for Hadoop that makes Hadoop can talk to Rados Gateway directly. The second is RGW-Proxy, which is like a daemon, a standalone daemon that can give out the closest Rados Gateway instance related with the Hadoop job, and then we have the RGW cluster over cache tier technology. So here is a general working flow for Hadoop over Ceph Rados Gateway. The first step is schedule the ask Rados proxy, which is closest active Rados Gateway instances for this job. And then the second step is scheduler would allocate these tasks to the servers that is near to the data, which means near the Rados Gateway instances. Third step is Hadoop job where we try to read the data through RGWFS. Basically, it's just some Rados RESTful requests. The last step is Rados Gateway would try to write data from the Rados cluster. Okay, so I'm going to introduce each of the components respectively.
Yeah, this RGW proxy I think is much like MDS. MDS is implement POSIX interface, and this RGWFS implement Hadoop interface.
Yeah, that's right. HCFS is actually a subset of POSIX API. It's similar to POSIX, but not a full set of POSIX API. Mm-hmm. Okay, so actually for RGWFS, it's just a similar fork of Swift FS in OpenStack Sahara project. except there are some minor changes. So, for example, in SwiftFS, the required URL of the objects actually includes some partition number here, 154362, and we know that in RGW there's no such sense. So we actually need to change it like below without partition number. Okay, so the second part is
sorry. Just one comment. In Swift, you get a partition number by authenticating to the auth server. You get the entire URL. The same would be if you actually authenticate to the gateway through the Swift authentication. But I assume you are not really authenticating, right, in your environment.
Yes, exactly. So for the first step, we tend to do not use authentication systems here.
Yep. Okay.
Okay, so for the second part, we have actually this is a most complicated part for this solution. We have a standalone daemon that acting like a name node in HCFS. So before each get put, RGWFS would try to query RGW-Proxy to get the block location from block locations in Rados cluster. There's actually a mapping from Rados gateway object to Rados objects. So the first requirement is RGW-Proxy will need to understand the mapping from Rados gateway object to Rados objects in order to achieve data locality here. And the second requirement is so note that we are actually using cache tier here, and RGW-Proxy would need to understand the crush mapping or rule between base tier and the cache tier, and it need to calculate the dedicated OSD in cache tier, so that we can tell which RGW instance is closest to the data in cache tier.
So is there any reason why you'd want to make a new daemon, and as opposed to just adding a new command or whatever to the existing RGW?
It could be standalone, just providing some RESTful interfaces.
Mm-hmm.
Or we can make it RGW component, but I doubt that there's no other projects using this component.
I mean, it'd be a pretty generic command though, right? It would be just like, instead of a get on the object, you would just basically say, give me the layout, tell me which nodes this maps to.
Yes, you're right.
Yeah, I can probably do it like add some gateway management RESTful command, like RGW/admin/object/object name, bucket object name, and it'll give you back the mapping, something like that.
Yeah. Is that already implemented here?
No, it's not implemented yet, but adding that should not be that complicated.
Yeah. It seems relatively easy to add that to RGW versus creating a whole new daemon that then links in all the libraries and understands the same object name mapping. That whatever would be a lot of work. Just be duplicating all that functionality.
Right. You can take a look at some of our admin RESTful APIs and how they're implemented, and it's not a huge deal.
Okay. Okay. So actually, there's another requirement that RGW-Proxy need to monitor this RGW instances, so that RGW proxy can do some failover thing. We plan to use monitor Ceph monitors information here. Is that reasonable?
Sorry, the failover for what information?
I mean, is there a existing way to monitor RGW instances? If it's dead or alive?
Not at the moment. Sage, can the new watch notify system give you some indication about liveness of all the watchers?
The old one could actually. I mean, well, it will tell you whether the watch is registered, which is accurate to within like 30 seconds, which might be enough.
Yeah, but do you know registered by whom?
Yeah, it shows you the watcher IP.
Yeah, so you can
maybe
probably
the new one does. Yeah.
Mm-hmm. Right.
I mean, is that sufficient? Just knowing the IP address of the RGW? You'd have to map that back somehow to what host it is, but
is that sufficient?
Yeah,
yeah. Okay.
Yeah. Okay. Okay. So so this is the third part. This is pretty much some no development work needed here, just some deployment work. We tend to build a RGW cluster with Ceph cache tier. Note that there's only one cache pool for all these RGW instances, so that we can bypass the cache coherency issue there. The first step is we need to configure the RGW instances using some dedicated chunk size with RGW max chunk size and RGW object strip size. I think that's already done since Firefly, right?
Yeah, I think that was introduced at Firefly.
So if I need to using a dedicated chunk size, for example, 64 megabyte, I just need to configure these two values to 64 megabyte, and is that all?
Yep. I know people are setting it to like 5 megabytes or stuff like that. So yes.
Oh, okay.
The max chunk size controls how much data you read in a single Rados operation, and the object stripe size, I think so.
It's how big the object is.
It's what's the maximum size that each Rados object is going to be.
So you probably want like 2 or 4 megs for the chunk size, maybe, and then the stripe size would be 64 meg.
Mm-hmm.
Okay. Oh, that's great. That's great. So second step is so following the RESTful interface, RGW could try to get or put the content based on account container object name. So in the first step, first design, we tend to use some range read request to get each chunk or block here. Is that already done in current RGW interfaces?
Yeah. RGW supports range variation.
Okay, so that means if I use three clients reading same object, each using a range request, each client can get the specific date it just once, right?
Right.
Okay.
Like, if I understand it correctly, each RGW you'll send the request to the RGW that you know that is closer to the data, right?
Yes. Yes.
So you might have one read that's split into a few chunks, and each chunk is going to go to different RGW.
Yes.
Yeah. Just note that with this setup, each RGW is going to do two reads. It's going to read from the head object that is not necessarily close to it, and then read the range as it is now.
Oh, okay.
Mm-hmm. The head object is small, at least.
It might be empty.
So
you can probably set it up so that there's no head. The head object only contains the object's manifest and the metadata.
Yeah.
Okay. So Yehuda, let me try to confirm with you. So each range read request actually will issue two Rados reads.
Well,
the first goes to the head object.
At least two, depending on how you configured it. But the first read is going to be to the head object, and the next one is going to be to the actual range that you specified.
Okay.
Yeah, but you might
so if
you might be able to do something like if you could send the metadata somehow to the gateways from RGW proxy and add something to the gateways so that they don't need to read the head object, and I think you can do it. Then it's not going to read the head object, right? You need to modify the RGW to do that. But if the RGW proxy already knows that,
Well, remember RGW proxy is actually RGW /get layout / container / object, right? But it would have one of those things would be this is the magic URL to use to read the range directly.
Right.
And when provided that URL, it would just go directly to Rados, basically.
Okay, so how about if I configure the head object size to be 0?
Mm-hmm.
Where there still be two reads?
Yeah, well, the RGW itself doesn't know what the head size until it reads it, right? It needs to go to see each RGW instance needs to go and get the object's mapping for each read, unless you send it to it, unless somehow you send the mapping to the RGW instance.
Okay.
Yeah, I think that would be sort of a second pass optimization. So first step would be to add the get layout that just tells you all the layouts, and then you would just suffer that you'll read the head each time, but it's cheap.
Mm-hmm.
And then the second thing would be that get it layout would also just have you this long, encoded string that you pass in the URL when you're reading the chunks, and that would contain all the same information that would have read out of the head, so it can skip it. But I would leave that as a second pass optimization, probably.
Yeah.
So Yehuda, one question here. So how actually RGW will be knowing that, how this proxy will be knowing that which RGW is closest to the data, because RGW don't know where actually the data resides in the Rados cluster, right?
Right.
Yeah. That's the thing I'm going to talk next up. So this is a sample get flow for the RGWFS. So this is a bit tricky here that RGW proxy needs to. So for example, RGWFS is going to get one object called object 1, and RGW proxy would try to look for this file in a specified container. So note this container is previously configured by some operator in some config file. So RGW proxy needs to look this file with some header request to one RGW instance. So this is a RESTful header request. Then RGW instance would return the manifest file in the header object, and then we actually got the Rados objects in the Rados cluster.
Yep.
Okay. So once we got these Rados objects, RGW-Proxy can do some lookup by using crush. For example, we can first get the locations for these objects in the base tier, and then by using some internal functions, I can't remember the exact name, but it's something like we calculate object location in cache tier, and so we can actually got the target OSD for these objects in cache tier. So so actually we can know which RGW instance is closest from the data.
Yep, I think that makes sense. I'm not sure.
No, I'm still don't understand that how you were saying that it's closest to this means based on this means you are saying that these are geographically separated, these RGW instances, and which one is
on different tracks, not
yeah. So each OSD in cache tier actually has some like IP address, right? And then we can tell.
So basically, based on this crush location, you will determine that this where this RGW is running and this where this exact primary OSD or those OSDs are running. Okay, got it.
Yeah, in the same rack.
Got it. Yeah. Thanks.
And that mapping from the OSD's IP or OSD ID would happen somewhere in RGWFS, where it knows what all the RGW instances are, and it has the mapping. And it
it's actually
which RGW gateway is the closest.
Yeah, we can maintain some mapping table in RGW-Proxy, either by IP address or some user-defined rules. Okay, so then goes to the normal flow. Scheduler would try to send the task to the server that's on the same rack, and RGWFS would need to issue some range reads to get the blocks.
Sorry, Cesar, I have a question here. Would it be possible that for example, some data is previously in rack 1's cache tier, but somehow it will be changed to rack 2's cache tier?
There's only one cache tier, right?
Yeah, only one cache tier. But for example, when we're looking up for which RGW to be returned, we need to calculate the mapping relationship. For example, if we calculate that one object's cache tier is actually belong to RGW1's the OSD in the cache tier, would it be possible that due to some unknown reasons that some days later the object is actually cached, each cache tier SSD is actually in rack 2?
It's going to be moved. Yep.
It's possible.
Yeah.
I mean, I think it wouldn't really matter. It just means it would be that one object would be slower, or that one placement group probably. So you're saying like if an OSD failed or something and data got shuffled around?
Yeah, in that case, locality. So we may tell the client that the data is actually previously we told them it's on RGW1, then we told them it's on RGW2.
I would guess that's a
sorry.
I would guess that the RGWFS is only sort of believing that to be true for a short period of time. Like this is over the lifetime of a Hadoop job or something. The data is probably not going to move. Maybe over the course of days and days it might, but
I remember. I think it's reasonable to have some cross-rack read if there's some OSD fail in cache tier.
Yeah. Is it sufficient if we only give it one location? Like if we only tell it the primary, and the Hadoop only think that there's one place where it can read it, and we always is that sufficient, or do you want to be able to read from any replica?
It would be nice to have multiple replicas in the place.
Okay. So that isn't supported yet. We need some. There are some bug fixes that need to happen on the OSD for read from replica, and then there'd have to be an additional an additional hint that RGW would understand, so that it knows that it's allowed to read from replicas.
Yeah, actually, these RGW instances can read from the below cache tier. So we actually can give some random RGW instances there. Just make sure the first one is the right one.
Yeah. Okay.
So here comes the sample put procedure here. Basically, it's kind of a reverse procedure for sample get. So when put happens, that means there's some reducer for the Hadoop job. It's trying to write some data to below Rados cluster. So the scheduler will first ask RGW proxy for the location of some big data file. RGW proxy actually monitors these instances and then returns an active RGW instance list, which the first one is actually the closest one, and the second and the third that should be configurable by user. Can actually be some other Rados gateway instances. So you can have some failover. Okay, so next step, Rados writes these outputs to RGW through some RESTful put, and RGW would split the objects into multiple Rados objects. So this is a put process here.
So this would be a cross rack Rados, right? Then.
Yes.
Right.
Okay.
Yeah.
And that's okay.
There might be some. Yeah, it's okay.
Well, in fact, it probably always will be because we're replicating it, presumably across. racks.
Yeah. Yes.
Okay.
I have a question. During a specific run, are objects going to be overwritten?
So typically there'll be the input date might be you can consider the input date would be read only, and then all the output will be some new objects.
Right.
There is no overwrite. I think only append is supported in HCFS in the MapReduce, right? So there won't be overwrite in the Rados layer.
Right. How does it append, by the way, using S3? Because there's no append there. So.
Yeah. That's actually an issue here. So for the first step, we'd like to keep this in the design. I mean, when you run a Hadoop job in this cluster, you have to configure that the outputs are actually written to some new objects.
Mm-hmm.
So we can bypass append issue here.
So if objects are not going to be overwritten, then you can probably do some kind of a tweak where the names of the Rados objects are deterministic, at least deterministic for that specific run.
Yeah, exactly. This is let me try to turn to the next page. Yeah, this is we tend to some discuss with you guys here on the modification on RGW side. So the first is it possible to use some pseudo random string in shadow object names? I mean, we can rely on some MD5 of the entire URL of the container object account names. Instead, currently we are using some base 64 strings in these channel names?
Well, the actual full name currently contains the bucket ID underscore, then some random string, and maybe a suffix. You can still do kind of the same, like the bucket name is constant, the object name is constant for that object, and then you can have some kind of another pseudo-random string for like that you can choose, or it doesn't need to be actually pseudo-random. It can be, I don't know, the job ID or something like that.
Yeah. So is there an existing way to do this in current Rails gateway?
No, that you need to.
Oh, okay. So
modify.
we need some modification here.
At the moment, it just create a random string.
Okay. So next question is, so is there any multiple uploads API for Swift? I mean RGW Swift API?
Currently, the Swift API that we support is the regular upload and the DLO, the dynamic large object. We don't do this static large object, although I did look at the API recently, and it's not that different from the dynamic large object. So it's, well, we would be happy with if anyone would be want to contributing that code.
Okay,
it's really not that different from the dynamic one.
So the reason I ask, because if you want to do some append write, I mean, we can actually rely on multiple uploads.
Right. Actually, dynamic large objects should do it, right?
Yeah.
So we do support that.
Okay. All right. So this is pretty much the work I have here. Thank you, Yakuda. Thanks, Sage.
All right.
Thank you. Okay.
What do you plan to integrate it in Sahara then, if it's done?
Oh, it's yeah. I think it's good to contribute back to Sahara so that we can have another choice in this project.
Yeah, okay, great.
Sorry, I have yeah.
Mm-hmm.
Yeah, I have a main concern is that this solution mainly solves the problem about zero copy of Sahara using Ceph, and I think it will introduce another problem that exists in real use case. For example, if I mention the SwiftFS, the problem, performance problem, because we know that I/O performance is very important for Hadoop job performance, and I think this BP introduced lots of I/O layer to it, and I guess the performance degraded that this BP introduced. So I just think up with another way of make it a zero copy, but performance not degraded. So this BP move let RGW simulate Hadoop interface, and it let this zero copy. So it is possible that MDS, another word, CFS, read directly from RGW. So I think it may be more performance better. So we may introduce a middleware between RGW and CFS. So it may get better performance between Hadoop and CFS, because we don't have a lot of I/O layer between this. And the more reason that Hadoop often run out of many data, and I very concerned that real user will consume much of network better ways if for this solution. And I just think of this idea maybe for performance and maybe a little dirty, but I think it maybe work better for real use case and for cloud solution Hadoop.
Your concern is that the data is passing from the client to the gateway and then to Rados? It's that hop that you're worried about?
Yeah, Swift FS, because of the simple interface, it doesn't really performance effective for Hadoop job, especially for much of Hadoop complex job. It will using Hadoop interface, which allow offset and length, and Swift only get full and put full. So it may be existing some gap with this. Yeah.
And the alternative that you're suggesting would be to have Hadoop talk directly to Ceph RGW, like using their existing plugin, or you would still? I mean,
let me clarify one thing here. The MapReduce client, they cannot access the Rados class directly. The only way they access the backend store is through the gateway. So that's why we're using RGW here.
I know that. I mean that we made pass some hit to Ceph S, and it can direct read from objects stored in RGW.
You want a layer? You want a layer like libCephFS on top of RGW?
Yeah. It's maybe a little dirty, and it may middleware. Yeah. Yes, because we have because we have a similar solution for Hadoop with Ceph, and I think one problem is zero copy, which this BP slowed, and another problem is performance, and we need to take care for zero copy and performance.
Yeah, I mean, I'm confused by zero copy in this context because we sort of explicitly do have to copy. Like there has to be this intermediate proxy.
Let me clarify. And this because Sahara using a Swift source data, and it is stored in a Swift or Ceph RGW cluster, and so we must read from Swift LS. Oh, sorry. Because we the Sahara store data in RGW, and we need to enter your conference code. if we need a Hadoop using this data, we need to copy from RGW and into the data that Hadoop can directly access. Yeah. So I come up with an example. If user has a very large data source that it may several TB or several hundreds of TB, and we need to move this data from RGW or Swift to the the Hadoop data backend, such as HCFS or Ceph RGWFS. So this hundreds of TB need to move one place into another place, and
I think I understand. So, that doesn't happen here.
So
right?
this so there's actually no copy in RGWFS. It's just some abstraction layer that using RESTful interfaces. So there's no data copy here. It's just this data actually read through RGW instance through RESTful interface.
Yeah. I know this BB can do this. Yeah.
Okay. Maybe do you mind following up over with an email, maybe explaining what the other option is? I'm not quite capturing it.
Okay, I will talk to you with emails.
Oh, thank you.
Okay.
That all for that one?
All right.